All right, the first move in simplifying this expression is I'm going to apply the power to power rule that says that this negative 2/3 gets multiplied to the exponents of each of these factors inside the parentheses. The maybe interesting difficult thing here is that we think of this as an 8 to the 1, and we think of this 8 as being separate from the a here. Those are separate factors. And so what I'll get here when I apply this negative 2/3 is I will get 8 to the negative 2/3 times a to the positive 7/3. And that's all over this a to the 5/24. Real quick recap on where this 7/3 came from. I'm taking this negative 7/2 and I'm multiplying it by this negative 2/3. And this common factor of 2 gets canceled between this numerator and denominator. And I multiply straight across. Negative 7 times negative 1 is a positive 7, and then 1 times 3 gives me a 3 on the bottom. So that's where this 7/3 comes from. All right, the next thing I'm going to do is I'm going to take care of this 8 to the negative 2/3. I'm going to take this factor here and I'm going to move it into the denominator, and what that's going to do is remove the negative from the exponent. And so what I'll have now is an a to the 7/3 in the numerator. In the denominator, what I get is an 8 to the 2/3, now positive 2/3 because I've moved it down, and then this a to the 5/24. Let me move these apart a little bit so it doesn't look so hard to look at. Okay, now what I need to do is I'm going to combine these a factors. I do that using subtraction. What I'm going to do is subtract this exponent of 7/3, actually subtract this 5/24 from the 7/3. So I got this 7/3 minus the 5/24. I need a common denominator now that I'm subtracting, so I'm going to use the common denominator of 24ths. And with this 7, I need to multiply the top and the bottom here by 8. So I'll get 56/24 minus the 5/24 here, getting 51/24, and I need to reduce that. When I reduce that, I get cancel this common factor of 3, and I'll get a 17 up here and an 8 down here. So what I have now is this a to the 17/8. Whenever I do this and I subtract the exponents from each other using this quotient rule, the result is always in the numerator, by the way. And then I get 8 to the 2/3. The last thing I need to do now is I need to evaluate this 8 to the 2/3. This is just a number. It's the property of rational exponents. I'll do this on the side. So 8 to the 2/3. I'm going to rewrite this in radical form. This 3 is the index of a radical, and this 2 is the power. So I'll write this as the cube root of 8 squared. Again, this 2 is the same as this 2 in the numerator, and this 3 in the denominator becomes the index of this radical right here. And then to evaluate this number, the cube root of 8 is 2. So I'll get is 2 squared, and 2 squared is 4. So I'm going to replace this 8 to the 2/3 in the denominator with the 4 that is equivalent. And this is now my completely simplified expression.